Assalamualaikum and selamat sejahtera. Okay, so I'm Dr Aisyah binti Jahidin. Okay, in Physics 1, the first topic that you will learn is linear motion, which is kinematics in one dimensional. So the motion is either in the x direction or y direction, which is also called as freeform motion. Okay, as you can see here, there are some important parameters that involve in the kinematics. Okay, what is the kinematics? Okay, kinematics is the concept that are needed to describe motion. Okay, when we consider the effect that causes the motion, which refers to the forces, the study is categorized under the dynamics. Okay, as in Physics 1, the topic is related to the mechanics, so you will learn a lot on the kinematics and dynamics. Okay, I have divided my lecture notes on kinematics into two parts. Okay, in part 1, we will learn on the motion in one dimensional, which is either in the horizontal motion or vertical motion. Okay, so I have prepared two different videos that cover only on the horizontal motion, and another one is on the vertical motion. Okay, next, later we will focus on the motion in two-dimensional, which is also refers to the projectile motion. Okay, and then please take note that this study is just focused on the constant acceleration. Okay, so for the learning outcomes of part 1 and part 2, at the end of this topic, students should be able to define and distinguish between all the parameters that I've stated here. And then students should also know how to determine the distance traveled, displacement, velocity and acceleration from the appropriate graphs. And then students should also know how to use linear kinematics equations for uniform acceleration, and then describe and solve free fall problems. And finally, students should know how to solve projectile motion problems using kinematics equations. Okay, so this is the sub-contents that will be covered in the first part lecture. Motion is the change of position over time. We consider a moving object as a particle where it is best to represent it in a coordinate system. So the direction is positive for the right or upwards and negative for the left or downwards. So we can write a position of a car that moves towards to the right as positive 2.5 meter and negative 3 meter if the car moves towards left from the origin. Okay, parameters under linear motion can be categorized as either a vector quantity or scalar quantity. Okay, so what's the difference between a vector and scalar? Okay, if the parameter is categorized as a vector, it must have both of the magnitude and direction. Okay, the direction of a vector can be indicated by a positive or negative sign. Okay, as we can see here, we have two cases of the velocity and acceleration, which for the first case, if the sign of velocity is equal to the acceleration, or we can say that both are in the same direction, so the velocity is increasing, or we can say that the object is accelerating. Okay, if we have the sign of velocity is not equal to the acceleration, which means that the direction of velocity is in the opposite direction of the acceleration, it means that the object is decelerate or it is slowing down. Okay, so for the scalar quantity, the parameters only has the magnitude. Okay, so this is the 4 basic quantities in kinematics. Okay, as I mentioned earlier, that motion is the change of position over time. So it is important to mark the initial point and the final point of the motion, which indicates the displacement. And we can get the velocity and acceleration by the derivation of the displacement. Okay, so and take note here that for the initial velocity, we can write it as a v naught or u, and for the final velocity, it can be written as v. So this is the difference between distance and displacement. Distance is a scalar quantity and it refers to the length of actual paths an object has moved, whereas a displacement it is a vector quantity. So we must write the value with the positive or negative sign. Okay, and as we know that displacement is a change of the position between initial point and final point. Okay, let's see an example here. Okay, let's say you walk from your house to friend's house, then to the grocery shop. Okay, to find the distance traveled, we need to total up the path taken from your house to the grocery shop, which we get 8.5 meter. And then to find the displacement, which refers to the difference between the initial point and the final point. So you will get displacement as a 4.3 meter. Okay, so for the next question, an athlete runs 4 laps of a 400 meter track. Okay, what is the athlete's total displacement? Okay, as you know that the athlete run the initial point and the final point is at the same position. So the displacement is equals to 0 meter. Okay, speed and velocity. Okay, the SI unit is meter per second. And as we know that speed is a scalar quantity which refers to how fast the object travelled regardless the direction, and we can get the speed by using this formula. Okay, for the velocity, it is a vector quantity which refers to the speed in a given direction. Okay, so the velocity is displacement over time. Okay, at this point, it means that we can also have an object that travelling at a constant speed with a changing velocity, which is in terms of direction. So this is a concept that you will learn later in a circular motion. Okay, given a particle initially at position x0 equals to 90 meter at t0 equals to 1 second. Okay, it moves to position x1 and then to position x2 and come to rest at x final equals to 19 meter at t final at 6.1 second. Okay, and then to find the average velocity, we need to calculate the change of the position, which is x final minus x initial divide by the time interval. So we get the average velocity as 0 meter. Okay, and then for the average speed, okay, it is easier if you can sketch as shown in this figure. Okay, to find the average speed, we need to find the total distance of the motion and divide by the time interval. So we get the average speed as 85 meter per second. Okay, we have a car travels 40 km to the west and 30 km to the south. Okay, and the entire trip takes is 1 hour. Okay, to find the speed, we need to sum up all the actual parts of the car and divide by 60 seconds. We must write it in a SI unit. Okay, so then you get the answer. And then for the second, to find the velocity, as we know that velocity is a vector quantity, so we need to add the x component and y components using vector technique, which refers to the hypotenuse of the triangle, and divide by 60 seconds, then we get 833 meter per second. Okay, the average velocity can be found by calculate the change of position over time interval. Okay, this is represent the slope of the position versus time graph. Okay, if let's say we want to find the instantaneous velocity, which means that the velocity at certain point and at certain time, so we need to calculate the slope of the tangent to the curve. Okay, let's say if we have the value of the velocity which refers to the dx over dt is same at any time, so it means that the object is moving in uniform velocity. Okay, this can be represented as in a velocity versus time graph. Okay, and if you see here, we have the same of the velocity value at any time. Okay, for the acceleration, we can find the average of the acceleration by calculate the change of velocity over time interval. Okay, this value is represented as a slope of the velocity time graph. Okay, for the instantaneous acceleration, which refers to certain point of the graph. As example, if you want to find the instantaneous acceleration at point P or point Q, so we need to calculate the slope of the tangent to the curve. Okay, similar to the velocity, if we have the value of the instantaneous acceleration is same, it means that we have the uniform acceleration. Okay, the characteristic of the motion can be represented by using graphical methods, which we have the position versus time, velocity versus time, and acceleration versus time graphs. Okay, for the first case, if the object, the velocity of the object is increasing uniformly, it means that the object is accelerating. So we must write the acceleration as a positive. The sign of A is positive. Okay, so when we look at the first graph for the ST graph, we will have a positive curve slope. Positive curve of the slope. So it refers to the velocity that is increasing. Okay, and when we move to the second graph for the VT graph, as I said just now, V is increasing uniformly, so we will have a positive slope of the VT graph. Okay, and for the third graph, as you can see here, we will have a stagnant line for the AT graph. It means that the A is constant, and the graph is plotted on the positive side of the graph, which means that the sign of A and V, or we can say that the direction of A and V are in the same directions. Okay, for the second case, if the velocity of the object is decreasing uniformly, so we said that the object is decelerating, then we have to write a negative sign A. Okay, so when we look at the first graph or the ST graph, we will have a negative curve slope of the ST graph. Okay, and also a negative slope for the graph, for the VT graph. Okay, and for the third graph, which is for the ET graph, we will have a stagnant line of acceleration, but this time this is plotted on the side of the negative graph. Okay, it means that the direction of A and V are in the opposite directions. Okay, for the last case, if the object is moving at a constant, or we said a uniform velocity, so we will have A is equal to 0, because the object is neither accelerating or decelerating. Okay, so then as you know that if the object is moving at a constant speed, it moves at a constant speed, then we will have a positive straight line for the ST graph. Okay, then for the VT graph, because the V is constant, so we will have a stagnant line, which means that the V is same at any time. So the V is constant. Okay, and for the third graph, which is for the AT graph, because A is equal to 0, so you cannot plot any point here. Okay, this means that the object is either at rest or it moves at a constant or uniform velocity. Okay, and then for the case of, okay, let's say if you want to use the same graph, okay, let's say from the AT graph here, if you want to find the velocity, so we can find the velocity from the AT graph by calculate the area under the AT graph. So Okay, the area under the AT graph will represent the velocity. Okay, let's move to the second at the center here. Okay, let's say if you calculate the area under the VT graph, it will represent the position. Okay, this I have summarized here. Okay, let's see some exercise. Okay, for number 1, what is the acceleration of the object between 2 seconds and 6 seconds? Okay, for the VT graph, as we can see here, the velocity is constant, or we say as a uniform velocity. So when we have a constant velocity, it means that the object is not accelerate or decelerate. So A is equals to 0. Okay, for the number 2, what is the magnitude of acceleration of the object between 6 seconds and 10 seconds? Okay, again, if you are from the VT graph, the acceleration is represented by the slope of the graph, which means that we need to calculate the change of the position, the change of the velocity versus over the time interval. Okay, so for number 3, how far the origin does the object move in first 6 seconds? How far indicates the position of the object. So from the VT graph, if we want to find the position, we need to calculate the area under the graph in 6 seconds. Okay. Okay, these are the generate kinematics equations in constant acceleration. Okay, usually we will use a lot on the first, second, and fourth kinematics equations. Okay, steps of problem solving using kinematics equations. Okay, first and foremost, of course, you need to read and understand the given problem. Okay, this part is very important when you want to solve any problems in physics, which it is highly advisable for you to sketch or draw a diagram. Okay, in this case, I mean for the kinematics, you may sketch the object as a point of particle. Okay, and then we choose a coordinate system, label the initial and final points for your reference. Okay, and then indicate a positive direction for the velocities and accelerations. Okay, and then label all the quantities and make sure all the units are consistent, which in physics we must use the SI units. Okay, and then choose the appropriate kinematics equation, and finally you can solve the unknowns using the equations that you already choose. Okay, before we end our first lecture, we see an example here. Okay, a car travels at a straight road with a speed of 24 meter per second, decreases uniformly to 8 meter per second by traveling 40 meter. Okay, because the key word is uniformly, so we can apply the kinematics equation to solve this problem. Okay, for A, we need to find the deceleration of the car. By using the second kinematics equation and substitute all the parameters given, which is this is a V initial, and then this is our V final, and then this is our displacement. So substitute all the parameters into the equation, then we get the A is equals to negative 6.4 meter per second and negative 2. Okay, the negative here indicates that the car is decelerates. Okay, and then for the V, we need to calculate the time taken for the deceleration. Okay, by using the first equation and substitute all the parameters that already given in the equation, and also from the equation number A, then we get T equals to 2.5 seconds. And for last question, before we can calculate the total distance traversed before the car stops, we need to find the T because when we see here, the keyword here is the car stop. So the V final now is equals to 0. So we cannot take this as our V final, because now the car is stopped. So we need to find a T for the time taken here. So by using the first equation, and then V final is equals to 0, then you get the T is equals to 3.75 second. And for then now we calculate the total distance by using the Ford's kinematic equation, and we get the answer as 45 meter.